Good day, everyone. Good day, Ms. Shireen Sinarain. My name is Metro Siratan, and this is my project on ionic and covalent bonding. In this project, we will be talking about one ionic bond and one covalent bond. The ionic bond being sodium chloride, NaCl, and the covalent bond being diamond. In this project, we explore the physical and chemical properties of two distinct components, sodium chloride and diamond. Sodium chloride, which is commonly known as table salt, is representative of ionic bonding, while diamond exemplifies the characteristics of covalent bonding. Understanding the properties of these compounds sheds a light on a diverse nature of chemical bonds and their impact on behavior of substance. Ionic bonding in sodium chloride, NaCl. Sodium chloride, commonly known as table salt, forms through ionic bonding. In this type of bonding, electrons are transferred from one atom to another. In the case of sodium chloride, sodium Na donates one electron to chlorine, Cl. The electron transfer results in a formation of positively charged sodium ions in a positive and negatively charged chloride ions, Cl negative. The electrostatic attraction between these oppositely charged ions holds them together in a three-dimensional lattice structure, forming the solid compound we recognize as salt. The covalent bonding in diamond. Diamond is a form of carbon where each carbon atom forms strong covalent bonding with four neighboring carbon atoms in a three-dimensional structure or arrangement. Covalent bonding involves the sharing of electrons between atoms. In diamond, each carbon atom shares electrons with four other carbon atoms, forming a network structure. The shared electrons create a very strong, rigid, three-dimensional structure, making diamond one of the hardest natural materials. The covalent bond in diamond is extremely stable, and this accounts for its exceptional hardness and unique optical properties. The physical properties in sodium chloride, NaCl. Sodium chloride exists as a crystalline solid at room temperature. The melting point of sodium chloride is relatively high, which is around 801 degrees Celsius, which is 1,474 degrees Fahrenheit, and it boils at approximately 1,413 degrees Celsius, which is 2,575 degrees Fahrenheit. The solubility. Sodium chloride is highly soluble in water, forming clear and colorless solutions. In a solid state, sodium chloride does not conduct electricity. However, when it is dissolved in water or when it is melted, it forms an electrolyte solution that can conduct electricity. The physical properties of diamond. Diamond is a crystalline solid at room temperature. Diamond is one of the hardest known materials, scoring at 10 on the Mohs scale of hardest on the mineral's hardness. Transparency. Diamond is transparent to visible light and has high refractive index, giving it brilliant luster. The melting point. Diamond has exceptionally high melting point of about 3,550 degrees Celsius, which is 6,422 degrees Fahrenheit, under standard atmospheric pressure. However, this does not have a well-defined boiling point because it sublimes directly from the solid to a gas under normal conditions. Unlike metals, diamond is an excellent insulator and it does not conduct electricity well. This is because all available electrons are involved in strong covalent bonds, leaving no free electron for electrical conduction. Diamond is a dense material with a density of around 3.15 grams per cubic centimeter. The chemical compounds of sodium chloride, NaCl. The chemical compound of sodium chloride is NaCl, capital N, common A, capital C, common L, indicating that it is composed of one sodium ion, Na positive, and one chloride ion, Cl negative. When dissolved in water, sodium chloride dissociates into its constituent ions, Na positive and Cl negative. This property is essential for its role as an electrolyte in aqueous solutions. Sodium chloride is relatively stable and unreactive under normal conditions. It does not undergo chemical changes in typical environmental conditions. Sodium chloride is neutral and it does not react with most acid or bases because it is considered a neutral salt. The chemical properties within diamond. Diamond is composed of carbon atoms arranged in a crystal lattice structure through strong covalent bonds. Diamond is not easily combustible and does not burn under normal conditions. However, it can easily react with oxygen at very high temperatures, forming carbon dioxide. Chemical stability. Diamond is highly chemically stable. It is resistant to acids and bases at room temperature. The strong covalent bonds between carbon atoms contribute to its stability. Diamond is generally inert and does not readily react to other substances. Its lack to reactivity is due to the strength of the covalent bonds within the crystal lattice. Unlike other forms of carbon, such as graphite, diamond does not oxidize, which means combines with oxygen under normal conditions. In conclusion, the exploration of sodium chloride, NaCl, and the diamond provides a comprehensive understanding of the distinctive physical and chemical properties inherent in the compounds with different types of bonding, ionic and covalent, respectively. Understanding these properties not only enriches our knowledge of these specific compounds, but also underscores the broader significance of chemical bonding in shaping the behavior and application of substances. Sodium chloride and diamond, each unique, serves as examples of the diverse outcomes arising from distinct types of chemical bonds, contributing to their respective roles in our everyday lives and various industries. Thank you. That was my presentation on ionic bonding and covalent bonding, NaCl, sodium chloride, and diamond. Once again, thank you, and if there are any questions, you can let me know, and I will be happy to answer any one of them.